Welcome to the official Karma Dog YouTube channel, the channel for people who like music and other stuff. Normally this is primarily a music channel, but today I'm sharing some cool sciencey stuff just because I think it's interesting. Here's where I live. Here's the town of Manitowoc, Wisconsin. I live on the south side between Red Arrow Park and Silver Creek Park. To the north, which we call Denort, is the town of Two Rivers. I lived in Boston for about 5 years, but eventually decided to move back, partly because I missed things like this. Lake Michigan. Why isn't it called Lake Wisconsin? Well, Michigan is on the other side, and we lost the twin costs. So, from this curved part of the lake, you can see from the south side of Two Rivers to Silver Creek Beach, which is about 10 miles. Standing on the beach, you can see pretty much nothing but water, unless you turn your head all the way to the side. Here's the view. Isn't it spectacular? I've had a lot of visitors say they couldn't believe what they were seeing. They had no idea it was that big. One visitor from Japan once told me, "That's not a lake, that's an ocean." As a kid, hanging out on that beach or even driving past it, as I have 1,000 times, stimulates your imagination. You start asking things like, why can't I see the other side? How far could I see? One thing I've always wanted to try, but I never had the time or the gumption, was to take pictures of one point from another as far as I could, just to see what I could see. So, a few days ago I got out my 16.1 megapixel Nikon Coolpix Pro P510 with 42x optical zoom. I took pictures of the northern shore from two different angles. The date was June 6th at 11:29 a.m. and I finished at 11:47 a.m. So about 8 minutes I spent taking pictures. It was about 66 degrees Fahrenheit, humidity was about 72%, barometric pressure was 30, 7 mile per hour north wind, and the water was extremely calm. I'm providing these numbers in case anyone wants to use them to factor things like diffusion or refraction into what I'll be showing you. If you look down from here to the beach below, you can see that this is actually the top of a small cliff. So after taking my first set of pictures from that top point, I climbed down this 48-foot cliff, which wasn't easy, and I got as close to the water as I could, crouched down so that my knees hurt, and the camera was about 3 feet above the water, and took more pictures. I took my last photo at 11:47 a.m. So here's where I took my first set of pictures, and here's where I took my second set, about 48 feet down. Here's a picture of the two viewing points from Google Earth. In addition to being 48 feet lower, I also was about 57 yards closer to the other shore than when I took my first set of pictures. So here are some pictures from the first vantage point. Here I'm not using the full zoom, but here I'm using the full 42x zoom. And as you can see, the detail is, if you ask me, that's really impressive, especially when you realize how far away you're looking. And here are some shots from the lower angle, from just right above the water. A nice one there. Notice the water's a little darker. That's because you're lower and closer to the water. I went through all the pictures and tried to find some identifiable landmarks from both sets so I could line them up and compare. Here's a great comparison. There's the Lighthouse Inn, which I highly recommend, and that's the Two Rivers Water and Light Facility, and here are some buildings at the Two Rivers Marina. Here are the same landmarks seen from above in Google Earth, and I'd especially like to look at the Lighthouse Inn. Here's a nice picture. Note especially this line of rocks that reach out not only from the hotel but all along the lake shore. The rocks are about 5 to 7 feet high, and they're always in front of the buildings. Here's my own picture of these rocks with some people sitting on them. Convenient for scale. According to Google Earth, these rocks reach out about 11 yards closer to the point from where I took my pictures. Here's another shot from Google Earth. There's the rocks. As you can see, this is not simply the bottom part of the hotel. In fact, they're not even part of the hotel at all. So, same spot, photographed from two different angles. First one was taken at 11:39 a.m., elevation of 633 feet, distance of 6.45 miles, 42x zoom, 65 degrees Fahrenheit, 72% humidity. The second shot, I'm 48 feet lower than the first shot. And do you notice anything different? If you look closely, in the first picture, you can see rocks. In the second picture, there are no rocks. Where did they go? Here they are lined up, right side by each. And as you can see, I have the tops of the same building in each picture lined up. And in the second picture, where you should see rocks, you see only water. So again, what happened? Where'd they go? Let's look at another one of these landmarks. Here's the marina. Notice that in front of the marina there is a 250-yard stretch of beach, about 100 yards in front of the marina building. And compare these two photos. In the first photo, you can see the beach. If you move down 48 feet and get even a little closer to the other side, the beach disappears. If the lake is flat, we should be able to see it from any angle. There is no way you should not be able to see a small object in front of a larger one, regardless of the angle. So you can be down low, you can get up a little higher and further back, still see the same thing if it's in front. I could go for a little swim in the water, still see the rocks. I could go paragliding, and I could still see the rocks. Now, what if the lake isn't flat? For a moment, let's use the commonly accepted model of the Earth, which is an approximate sphere with a 3,959-mile radius. Here comes the math, I'll try to be quick. The curve from my camera to the lighthouse is about 6.4 miles. A useful formula is that there should be a drop of 8 inches per mile squared along this curve. Using that figure, let's figure out how far this drop should be. And it turns out it should be a drop of about 27 feet. So that's more than enough to hide the view of the rocks, which are only about 7 feet high at most. Even if I adjust for the 3 feet above the ground I was holding my camera, there would still be 12 feet hidden by the water, more than enough. I won't bother you with the math, you can check it yourself if you disagree. This diagram isn't made to scale, but it gives a rough picture of what those numbers tell us. But let's consider some other solution. Where did the rocks go? Was it rising tide? Well, the tide in Lake Michigan does not rise 7 feet in 10 minutes. In fact, the most the tide ever rises in the Great Lakes is about 5 centimeters. The Great Lakes are considered to be non-tidal, so no. Were they hidden by mist? Go back and look at the photos. That's not mist, that's blue liquid water. Nothing but lake. Atmospheric refraction? I don't know. I did provide the temperature and the humidity, so maybe you can figure it out. What I've learned about refraction doesn't suggest that's the answer, but you tell me. Lens distortion? No, I don't think so. Lens distortion only changes the shape of the objects. It doesn't make them disappear from sight completely. Photoshop? No, I did not use Photoshop. Please correct me if I'm wrong about any of this. So what do you think? How do you explain the differences in these photos? Thanks for watching. Please subscribe. And the music is by Karma Dog. If you're interested, it's available at karmadog.bandcamp.com. Take it easy. See you next time.